Hello again. So in the previous video, we looked at how to solve an inequality and what an inequality is, right? If I know that x is greater than 3, right, then I know that I'm dealing with all of the numbers that are greater than 3 on the number line, right? We looked at that and we looked at solving them. They were pretty simple. The only thing that changed was, say I have a negative 2x is less than or equal to 6. Remember, if you do the action of multiplying or dividing by a negative number, meaning that I am doing that to solve, I'm the one doing the action, then I have to flip my sign, right? And so I end up with x is greater than or equal to negative 3. Right? That's all that we really looked at in the previous video. Most of it was just solving equations, right? It's that same process of isolating your variable, combining like terms, all that fun stuff. So the next thing that we're going to look at today is something called an absolute value. So the absolute value of a number is its distance from 0. On the number line. So because absolute value is distance, it's always positive. So if I have, say, the absolute value of 3, remember absolute value is those two big lines, right? The absolute value of 3, we can picture it like this. Here's my number line. Here's 0, 1, 2, 3. So 3 is right here. We want this distance right here. That distance is 3. 3 is 3 units away from 0. If I have the absolute value of negative 2, right, here's 0, negative 1, negative 2, 1, 2, right, here's 0. Negative 2 is 2 units away, 1, 2, right? So the absolute value of a negative number is positive. The absolute value of a positive number is also positive, right? All that you're doing is just changing that sign. If it's a negative, it becomes positive. If it's positive, it stays positive. Okay, so we've looked at these before, but we haven't really thought about the idea of what about the absolute value of a number? Let's say the absolute value of x is equal to 3. And then let's think about it for a moment and see if we can figure out what that would mean in terms of our solution. If we look inside the equation, one of those methods that we looked at previously, right, we can look inside here and we can think about, okay, what numbers would make this true? What numbers are 3 units away from 0? Well, 1, 2, 3, because that's all that this means. This is just asking us what numbers are 3 units from 0. That's the question that we're being asked. Well, one obvious answer is 3 is 3 units away from 0, right? 1, 2, 3. But we can also go the other direction. Negative 1, negative 2, negative 3. So this one right here is also 1, 2, 3 units from 0. So we end up with 2 different solutions. Most of these, you're going to end up with 2 solutions. I'm going to show you kind of the algebraic way that we're going to approach solving these absolute value equations because it kind of helps us when things get a little bit more complicated. I'm going to look at that same one. The absolute value of x is equal to 3. And the way that I like to break them down is we really have 2 cases. Right? And these 2 cases come directly from this idea right here. That I have things that are 3 units away from 0. They could be 3 units to the right, or they could be 3 units to the left. So when I look at this, I say, okay, this stuff that's inside could be equal to a 3. So I know that for my first case, x could equal 3. For my second case, the stuff that's inside here could be equal to the opposite of this right here. Okay, it could be equal to the opposite of this 3, so that 3 becomes a negative. With this one, it's a pretty simple one to solve. I don't have anything to do after this. I just get my same 2 answers with using this idea of a case 1 and a case 2. Let me give you another one that we can look at. Let's say I've got the absolute value of a 2x plus 1 is equal to 6. Okay? So with this one, it's going to be a lot harder to just think about. I don't necessarily think about what number times 2 plus 1 is 6 units away from 0. That's much more difficult to just conceptually think about than this one where I'm 3 units from 0, my number itself. So instead, we're going to look at this stuff inside, and we're going to start our case 1 and our case 2. So our case 1, our absolute value is all by itself. So I've just got the absolute value is equal to a number. I can just drop my absolute values for my case 1. 2x plus 1 is equal to 6. For my case 2, I'm going to write another equation. I'm going to drop my absolute values. So my stuff inside here is equal to a negative 6, right? This is where it's 6 units to the right of 0. This is where that stuff is 6 units to the left of 0. At this point, I just have 2 simple equations to solve. These are things that we've been looking at before, so I can subtract 1 from both sides. So I get 5, so x is equal to 5 halves. There we go. And then this one, subtract 1, I get a negative 7. And then x is equal to negative 7 over 2. So I get my 2 answers, okay? And both of these, if I multiply them by 2 and add 1, I end up 6 units from 0. So let's try another one. Let's look at one where maybe my absolute value isn't by itself yet. Maybe I've got negative 3 times the absolute value of x minus 4 plus 2 is equal to negative 4. Okay? No, I don't want negative 4. I want negative 5. Yes. Okay. So if I look at this one, I'm going to start. I want to get this thing by itself. This is what I want to isolate. So I'm going to start off by subtract. Oh, no, I did want a negative 4. Sorry. This is what happens when I try and make up problems. I'm going to subtract 2 from both sides. And so now I've got a negative 3 times the absolute value of x minus 4 is equal to negative 6. Now I'm going to divide both sides by negative 3 because I need this whole thing by itself, right? Divide both sides by a negative 3. And I've got the absolute value of x minus 4 is equal to 2. Now, some people, if they see a negative sign showing up inside of that absolute value, like an x minus 4, they want to cancel it. But we have to remember that unless it's a single number that I know what that number is, so if it was, say, a negative 2 or a negative 7, but there's no x, then that's the only time that I can get rid of them. If I've got a variable in here, this is called a binomial, right? I've got 2 terms. I don't know what this is, right? There's times when this might be greater than 0. There's times when this might be less than 0. It all depends on what x is. So that negative, I can't deal with it yet, but what I can do is set up my 2 cases, right? So I've got case 1 and case 2. Case 1 is x minus 4 is equal to 2. And then case 2, remember, everything stays the same here, but I end up with a negative sign that pops up there. So I've got that x is equal to adding 4 to both sides, x is equal to 6. Adding 4 to both sides, x is equal to 2. Okay? Let's look at another one before we move on to something a little slightly different. Let's say I've got the absolute value of x plus 4 is equal to negative 7. And take a moment and just think about that. Think about what this question is asking us. It's saying that the distance of this thing from 0 is negative 7. Can my distance ever be negative? In that case, that's a big no, right? My distance can't be negative, so this is no solution. That's a situation where it's nice and quick. We don't even have to do anything because I know that it can't be equal to 0. I can't have a distance, equal to negative 7. I can't have a negative distance, right? You can't drive negative 5 miles, okay? The next piece is absolute value inequalities. So these are going to be very similar to the absolute values that we looked at before, and they're going to be similar to the inequalities that we looked at in the previous video. It's going to combine the 2 ideas. So let's say that I've got the absolute value of x plus 2 is less than 6. So that means that the distance from 0 is going to be less than 6. Okay? In terms of solving these, just like before when I was looking at them and they were equations and I had my case 1 and case 2, it's going to work the same way. Remember, inequalities, we can really effectively treat them like that they're equations, there's that one little difference where if we do something where we're taking the opposite by multiplying or dividing by a negative, we have to flip our sign. So we're going to see that show up here. If I've got my case 1, the absolute value of x plus 2 is less, or sorry, eek. My case 1 is I drop my absolute values. There's no more absolute value. So x plus 2 is less than 6. And then for my case 2, I've got that my x plus 2, remember, I'm going to do something with a negative number. I am right now doing something with a negative number. I'm going to make this a negative 6, so I have to flip my sign. Okay? That's going to be the really important piece to remember. So I'm doing something with a negative number, and I'm flipping that sign around. On this one, I've got that x is less than 4. And then on this side, I've got that x is greater than negative 8, right? Subtract 2 from both sides, subtract 2 from both sides, right? So if I look at this on a number line, these absolute value inequalities are kind of fun. So here's 4, here's 0, here's negative 8. Notice how beautiful my number line is. I've put so much effort into it. With your number lines, this is truly what I would expect. I just want the numbers in the right order. I want some sort of an idea as to where 0 is going to be so that I can kind of see what your number line looks like. These are they open or closed? Open circles, right? Because it doesn't have that extra piece. If it had that extra piece to make it less than or equal to or greater than or equal to, then I would fill in the dot, but there's no extra piece, so they're open. Now, in this case, x is less than 4, so it's going this way from 4, and x is greater than negative 8, so it's going all the way this way, because it's going this way from negative 8, and it's going this way from 4. So all of these numbers in between negative 8 and 4 have an absolute value that is less than 6. Okay? How are we doing? Good? I hope. Let's look at another one, but truly this is pretty much all that there is. You've got a lot more examples and, obviously practice problems, but that's really all that there is. Let's look at one that's a little bit more complicated. Hold on. Sorry. Well, these aren't really that complicated. Okay. I'm going to give you one that's similar to what you've got in your homework that might throw you for a loop. So let's say I've got 6 minus x. The absolute value of that is going to be less than 3. Oops, there we go. So I'm going to set up my, or actually we'll do greater than, just to make it a little different. Okay, so I'm going to set up my cases, case 1 and then case 2, right? So for case 1, I'm going to drop my absolute values. Everything else stays the same. So 6 minus x is greater than 3. Case 2, I drop my absolute values. But remember, I'm going to be doing something with a negative number. I did something to make that a negative. So now I'm going to flip my sign. Anytime that you're looking at these absolute value inequalities, you're going to be flipping that second one around. So now I can solve both of these. I'm going to subtract 6 from both sides. So negative x is greater than negative 3. In order to fix this, I have to multiply everything by a negative. If I'm multiplying it by a negative, I've got to flip my sign again. So I've got x is less than 3. Okay? And then on this side, I'm going to do the same thing. I'm going to subtract 6. So negative x, ooh, that's not even, I don't know what I was doing there. Negative x is less than negative 9. Once again, I'm going to get rid of my negatives, so I'm going to flip my sign. X is greater than 9. Okay? So here's 3, here's 9. I have, once again, open circles, right? There wasn't an extra piece there, so I don't have to worry about filling them in. X is less than 3, so it's going this way. And then x is greater than 9, so it's going this way. And let's look back at our original equation, or inequality, and think about it. So the distance is greater than 3 from 0. The distance of this thing is going to be more than 3 units away. So it makes sense that we would get farther and farther away. We could have extra big numbers or extra big negative numbers. Those are both going to work because my distance is going to be greater than 3. If we look at the other problem that we just did, right, with this one, our distance was less than 6. So that's going to be those numbers in between, okay? If you look at your worksheet. Okay. They give you lots of examples there. Same thing like what I just did. The first 6 are those absolute value equations, right? Where you've just got your case 1 and case 2. 7 through 18, that's where you've got your case 1 and case 2, and you've got the inequalities going on. For some of these, you're going to have to get your absolute value by itself first, right? Remember, like we looked at when we were looking at those equations, we've got to get that absolute value by itself and then look at what's left. Okay? And just like I did with the last one, I've got worked out answers for all of those for you. I'll get those posted so that you can check your work as you go. And once again, you have just the actual answers too, so that way you can check and see what you've got. Okay? As always, if you have any questions or you need some extra help or a place to work, or if you need anything at all, just let me know. You can send me an email, give me a call, and let me know what I can do to help you out. Okay, hopefully this helps, and have a great day.